Welcome to the era of Industry 4, where manufacturing is undergoing a dramatic transformation. Powered by innovations like the Internet of Things, big data analytics, and artificial intelligence, factories are becoming smarter and more connected than ever before. But among these advancements, one technology stands out for its potential to reshape the entire industry: digital twins. These virtual replicas of physical assets are enabling manufacturers to optimize processes, predict issues, and drive efficiency. As we dive into this topic, let's explore how digital twins are setting the stage for a new wave of industrial progress. Digital twins are essentially virtual doppelgangers of real-world systems. Imagine having a detailed digital mirror of a machine, a production line, or even an entire factory. These models can be used throughout a product's lifecycle, from design and manufacturing to diagnostics and maintenance. By simulating real-world processes, digital twins help engineers and managers identify problems before they occur, streamline operations, and reduce costs. The flexibility of digital twins allows them to be broken down into subcomponents, mirroring the complexity of physical systems. For example, an aircraft and each of its parts can have their own digital twin, all interconnected for maximum insight. Digital twins, to reach their full potential, the data they rely on must be credible, verifiable, and transparent. Traditional manufacturing systems often use centralized data structures, which can become single points of failure or targets for corruption. This vulnerability makes it difficult to fully trust the information that digital twins use to simulate and optimize real-world processes. As manufacturing becomes more complex and interconnected, the need for a secure and reliable way to manage data grows ever more urgent. That's where blockchain technology enters the picture. Blockchain technology offers a decentralized approach to data management, ensuring transparency, accountability, and integrity. With its tamper-proof ledgers, blockchain guarantees that once information is recorded, it cannot be altered or deleted. This makes it an ideal foundation for managing the dynamic and sensitive data that digital twins depend on. By leveraging blockchain, manufacturers can create a trustworthy environment where every transaction and update is securely logged, providing a robust solution to the challenges of data reliability in digital twin systems. Fascinating aspect of combining blockchain with digital twins is the use of non-fungible tokens, or NFTs. These unique digital assets can represent the ownership and authenticity of digital twins and their physical counterparts. Each NFT is minted with a unique identifier, making it immutable and traceable on the blockchain. By integrating NFTs, manufacturers can securely manage and transfer ownership of digital twins, track their history, and ensure that every change is transparent and verifiable. This hierarchical tracking extends to subcomponents, creating a comprehensive digital record for complex systems. Proposed blockchain solution doesn't just manage ownership, it also ensures secure delivery of both digital twins and their physical assets. Using a two-key security system, proof of delivery is recorded on the blockchain, and participants are incentivized to act honestly through collateral payments. Once delivery and payment are confirmed, collateral is returned. Every transaction, including proof of ownership and delivery, is logged with the participant's blockchain address, making the process transparent and tamper-proof. This approach brings a new level of accountability and traceability to manufacturing operations. A blockchain brings many advantages, such as decentralization, transparency, and data integrity. It also comes with its own set of challenges. The lack of a central authority means there's no single entity to enforce rules or resolve disputes. Smart contracts which automate blockchain transactions must be carefully written to avoid vulnerabilities. Once deployed, these contracts are immutable, making updates or corrections difficult. Despite these hurdles, the combination of digital twins and blockchain holds enormous promise for secure, efficient, and transparent manufacturing. Researchers at Califa University are exploring even broader applications for digital twins and NFTs. Beyond manufacturing, these technologies have the potential to revolutionize industries like smart cities, healthcare, and the metaverse. By providing secure, verifiable digital representations of physical and virtual assets, digital twins and NFTs can unlock new opportunities for creators, investors, and consumers alike. The ongoing research aims to harness these innovations to solve real-world problems and drive progress across multiple sectors. As we look ahead, the integration of digital twins and blockchain technology is set to transform manufacturing and beyond. With enhanced security, traceability, and accountability, these innovations promise to make industrial systems smarter, more efficient, and more resilient. Califa University's research is paving the way for a future where digital and physical worlds are seamlessly connected, offering new possibilities for industry and society. The journey is just beginning, and the potential for positive impact is vast.